Just a minute. I will adjust the screen. Little bigger. Okay, now okay. Okay, just a minute. Some weight here. Reasonably okay. It's a gap in the back side. Just a minute. Let's see. But color is time being not required. Is voice fully clear? Voice clear fully? Voice clear means I will start. Clear, okay. I start now. Write heading. You can write heading for yourself only. See. I will put a light line because I can rub easily. Not dark pen. Conjugate beam method. Conjugate beam method. That is deflection of beams. Conjugate beam method for cantilevers. Cantilevers. Okay, now, before you proceed further, there is one important information is there. I will not solve too many questions. See, moment area method for cantilever, I solved plenty of questions, everything. Now, when I solve the two questions here on cantilever by conjugate beam method, suddenly you will realize that everything which you write with calculation part, whatever you write for conjugate beam method for cantilever is exactly same as whatever you write for statement may change. See, there you write displacement of point theta a minus theta b, etc. you write there. But finally, when you come to the final calculation part, see, statements, you know, I will solve two questions to make statements clear. It is 100% matching with moment area method. So, I will take one cantilever with the left side fixed, right side free. I will detail solve it. Side by side, I will explain what we was done earlier. It was not same question, but same question. If you solve by moment area method, what you would have written, I will write here. Then you will tell, surely, in future, left side fixed, right side free, conjugate beam method, do not do any problem. What we will do is, we will go back to moment area method. Each question will solve by conjugate beam method. Statement will change. Calculation will not change. Statement you can see from this question. See, the change of statement you can see from this question. Calculation common. Clear now? So, therefore, I do not want to waste time. Ditto same. Okay, now, once I solve this one, I will take a cantilever with the right side fixed. There also, I will show the calculation by conjugate beam method here. Then, side by side, I will write what you would have done if it is moment area method. Again, you will tell, oh, this is exactly same. Absolutely no change. When only change is how you start, that is how to find theta, what you write in moment area method or what you write in conjugate beam method. The statement will change. That you do two questions here. Okay, start. First, before going further, some information is there. See, I told earlier, see, it is the real beam. Make a note, real beam. This is corresponding conjugate beam. Corresponding conjugate beam. Conjugate beam. I will just, at the end of this chapter, I will explain all the concept required for objective questions. Now, see, if the real beam is simply supported, this is already over. Suppose I take beam AB, don't by heart AB, then conjugate beam also will remain same. This is simply supported beam, conjugate beam also simply supported beam. That is both same. Both same. Remember, hinge roller all you are not bothered because only vertical reactions. Hinge roller no effect. Okay, this is for simply supported beam. Already over. Now, for this is, now consider cantilever beam. Cantilever beam, or you make a note, in case of simply supported beam, simple support, you write, today only you write, simple support in real beam will become simple support in conjugate beam. See, simple support, simple support, simple support, simple support. So, there will be no change in the end conditions of conjugate beam. But for cantilever, remember, changes are there. See now, right here. One side is, see, cantilever means it can be one side fixed. I will tell you AB, this way or this way, anything, AB, AB. So, there will be one fixed end, one free end. Now you remember, these are the real beams. Real beams. Now, make a note. Fixed end or fixed support in real beam will become unsupported or free end in conjugate beam. Whereas free end, very important, free end in real beam will become fixed end or fixed support, okay, fixed support in conjugate beam. Or you can write one general statement. In case of cantilever, whatever is the end condition for real beam will get interchanged. Logic I will tell you at the end of the chapter. Interchanged in conjugate beam. Clear? Whatever end conditions for cantilever in real beam will get interchanged. Interchange means what? This will take that slot, that will take this slot. Interchanged in conjugate beam. Therefore, if the real beam is cantilever, conjugate beam also is a cantilever. But real beam where fixed end is there, that will be free end. Real beam where free end is there, that will be fixed end. Therefore, after all the statement, you write a sketch here. This I already remove now. Therefore, now write a sketch. See, very important, cantilevers. Cantilevers. I will put real beam. I won't write real beam, RB, now onwards. I write conjugate beam here. See, suppose real beam is like this. Now, it will bend like this. I won't waste time. Maximum deflection comes here, maximum slope comes here. How many times I have to tell that one? Macaulay's method told, Momentaria told, class after class shouted. Now you write. If you want, write here. This is the maximum deflection, this is the maximum slope. You write if you want. This real beam, if I call AB, don't by heart AB. This will change over to fixed end will become free end will become fixed end in conjugate beam. See, real beam here, that is the conjugate beam. Or if the real beam is like this, AB, again don't by heart AB, free at A, fixed at B, then this will change here, elastic curve will come how? It will come like this. Now, maximum deflection here, maximum slope here. Slope and deflection is for real beam, remember. Conjugate beam is imagination. This will become what? Fixed end here will become free end here will become fixed end. This is the conjugate beam. Fully clear? If fully clear, I will start the question. Full clear? Interchanging of support conditions for fixed beam and cantilevers. Okay. Now, maybe more logic of this I will tell in BSK class only. Why? Some sensitive matters are there. So, if I tell all those things in the general class, some will not understand. They will tell, we don't understand. No. Public, when I make the class, simple way. Okay, start now. First, question number 1. Only 2 questions, remember. Only 2 questions, because I will show you. Once I solve this question by conjugate beam method, side by side I will solve by Momentaria method. Then you will surely tell, sir, second question, with the left side fixed, right side free end, do not do in the class. Why? What all we solved in Momentaria method, we will solve. Okay, start. Question 1. By words, a cantilever beam, more information is there, is of length 4 meter. 4 meter. I will directly go for double loading. Why? Single point load is easy now. You know it. It is, I will call one end A, one end B. Okay. It is told in the question, cantilever beam fixed at the left end. It is told in the question. A cantilever beam of length 4 meter has fixity at the left end. It is loaded by 2 point loads. First point load is 60 kilonewton at the free end, 60. Okay. And second point load is 150 kilonewton at 1.6 meter from the fixed end or 2.4 meter from the P end. I will call the point C. Find maximum slope and maximum deflection for the beam. Then also find slope and deflection under 150 kilonewton load. That is at C. That is here at C. Under 60 not required. Why? Under 60 maximum will come. Okay, over. EI I am not giving. I am not wasting time with EI value. This is the first question. Okay. Systematically I will solve with all the principles now. Okay, start. Actually 2 class may be required. See, start. One by one. Before I start conjugate beam method, I will do one thing. Before I start it, I will first go for Momentaria method. Get the answer. Ditto answer will come there also. Okay, 1 minute now. I should see the board up to where I can write. 1 minute. Little more further, up to here. Up to here, no problem, I think. Yes, up to there, no problem. Sufficient. Okay, leave it. Now, time being, you tell the, see, correctly observe. Unknowingly, you are getting a repetition of Momentaria. You tell, wait, see, our real beam, 1.6 meter here, 2.4 here, split by split I want. I do not want 4 meter here. See, total 4, 60 kN at free end and 150 at C. This is the cantilever. I told you 1,000 times. See, cantilever beam, there will be a reaction here, this way, and a reacting moment here. But you don't calculate MA and VA. But I will tell you what is the reason I am writing. Because when you come here, when they want bending moment, some student will tell, sir, look left side, 0. 0 will come in the answer booklet, where marks are allotted. Fixed end BM is maximum. Okay, leave it now. Start. Now, this beam we want what? Every calculation. See, now, same question, I will solve by moment area method. Okay, see, it will not take much time because it's already solved earlier. So, briefly I will solve. Right, start. First, write the beam here. I want space, space problem is not there. I can manage. Write the beam neatly. Remember now, little changes are there. 1 point load here, 1 point load here. How much? 150 kilonewton here, 60 kilonewton here. This is A, this is B, this is C. This distance is 1.6 meter. This is 2.4 meter. Remember, at the fixed end, reaction VA will be there. Reacting moment MA is there. But I told you, you don't waste time calculating it. Because I told you one thing, for cantilever, look free end side. Do not look this side. Don't tell left side. Do not consider fixed end side. Consider free end side. Make a note. For both real beam and conjugate beam, for any calculation, consider what? Free end side. Free end side. I will not tell again and again. There is a limit for explaining. Okay, start. Now, if you are doing by moment area method, first you draw BMD. Okay, bending moment diagram. Okay, show the calculation. So here 1 minute now. Even for conjugate beam also, there it is called in moment area. We don't tell real beam, conjugate beam. Beam, that's all. But in conjugate beam method, given beam is called real beam. We need BMD for real beam. Instead of wasting time, I will calculate for this one, same valid there. Start. I told look free hand side. Calculation show, I will write, you write here. You write here. There, you write later. See, start. But when you calculate BM, it is sagging positive. Remember, sagging positive. Start. BM at B, free end. Look this side. Don't look that side. 0. BM at C equal to, look this side. 60, if you look that side, you require reaction and moment. Now I will not tell. If anybody tell, sir, I want to look left side, then don't come to my class. That's all. What I tell is the most effective method. If you know that much, if you can do alternative, why attend my class? You try yours, you also start taking classes. Start. BM here. Look this side. 60 into 2.4. Be careful, it is bending moment. So hogging minus. Answer. How much answer? Fast. Tell fast answer. One question slowly I will solve. I will not hurry. I will not hurry. Slowly I will solve. 144 minus. Okay. It is minus 144. All in kilonewton meter. Then next BM at A. Here, don't look this side. If you look this side, that moment is required. Look this side. 60 into 4. 60 into 4 and also 150 into 1.6. 150 into 1.6. This is hogging, negative. Both are negative. Answer, fast. Fast answer. Fast answer. Minus 480. Okay, now do one thing. Same calculation for moment area method also. Now, if it is moment area method, draw BMD. I told, do not use sign for BMD. Why? Because in moment area method, direction of slope and direction of deflection we decide by elastic curve. Therefore, here while calculating sign required minus, usually people write minus below the line. No, in these methods write above the line. Here answer is minus how much? 144. Here it is minus 480, 144. Then linear and linear. Okay, over. But moment area method, don't write minus sign. Over. Now, lengths are here only 1.6, 2.4. BMD over. Now, tell me, if it is moment area method, what we want is, we want one triangle will come, one trapezium will come. See, this is full 480. This full is 480. So what we will do? For that, we can divide like this. This is 144. This also is what? 144. Tell me, what is this one? Tell me, what is that one? In moment area method. Same in conjugate also. That value. That value in moment area method. That is 480. Total 480. Divide into rectangle and triangle. 336. Okay. 336. 336. This is the BMD. Then you draw elastic curve. See the real beam. Beam is like this. This way, beam will deflect like this. Blue color required. Okay, no problem. Both are black. 1 minute. Oh, this color is a new pen. I don't want. This way. And one more thing. In moment area method, original point is A. Your B will come here. Your C will come somewhere here. See? C will go there. Name the point in the elastic curve. This is elastic curve. Then, maximum slope. Draw a tangent here. This is your theta B. They want slope at C also. Draw a tangent. This is your theta C. Now, slopes are marked. Deflection marking. See, remember, slope at A equal to 0. Therefore, if you draw a tangent to elastic curve here, the tangent will be parallel to baseline. I told you. This is the tangent at A. This also is tangent at A. Therefore, if you want this deflection, you find what? You find this value. Displacement of B with respect to tangent at A. Displacement of B with respect to tangent at A, that itself is your deflection at B, itself is Y maximum. Tell yes or no. Displacement of B with respect to tangent at A, that itself is deflection at B. B, don't by heart A, B, C, D. B, that itself is Y maximum. Tell yes or no. Yes. And theta B is your theta maximum. First of all, some will tell, this you told hundreds of times earlier. Over. Now, theta A0. Later, if you want theta C, you want. Okay, now, remember, find what is this value. See, this is, I'll write here, light line, displacement of C with respect to tangent at A, that itself is deflection at C. Correct? Yes or no? This all told endless number of times in moment area method. This all told endless number of times in moment area method. Okay. Now, time being tell, hey, wait for some time. I'll come back to you. Come to conjugate beam method. Draw the BMD. I told you, in moment area method, do not use minus sign here. If you use minus sign and again use sign for slope, it will have you wrong, direction wrong. We want only area and CG here. See, remember, this CG is here, this CG is here, this CG is here. Later. Okay, now. But right, everything you are right. In conjugate beam method, you need sign for the BMD. Reason, right? Because in the conjugate beam method, we are going to consider BM by EI diagram as a loading diagram. At that time, If BM is plus, loading is down. If BM is minus, loading is up. Therefore, you need sign. So that's why I wrote sign here. Okay. Now write. Now write BM by EI diagram. See here. 0 here, 144 here. So 0, written here. This is 144 by EI. Then here, total is 480 by EI. If any space is there, I will write here. Total is what? I will write somewhere here. 480 by EI. Hope it is visible. Visible? Board edge is visible. What I wrote, 480 by EI. Is it visible? Tell me now. That 480 by EI I wrote. Actually not visible means you can imagine what I told. Okay, total 480. Now what you do is divide into two parts here. See, this is 144. See, this is 144. Total 480. 144 rectangle. Remaining is 336 by EI. Do you want me to explain? Do you want me to explain how this 336 came? Tell fast. No one should tell yes. It may take 1 hour. Do you want me to explain how that 336 came? No. Why? It will be insulting. Total 480, one rectangle part is considered, remaining is 336. Now very important, this is BM by EI diagram, below right conjugate beam. Right here, be careful. In conjugate beam, what? End conditions, interchange compared to real beam. Now, those who want right here, real beam free end will become fixed end. Real beam fixed end will become free end. Fully clear? In conjugate beam, end conditions will change. Fixed end there will become free end there will become fixed end. Fully clear this one? Clear or not? Okay, now actually some will surely tell, sir, simply supported beam, conjugate beam method is very useful, correct? Especially if change of EI is there or unsymmetry is there. Cantilever beam, nobody will use conjugate beam method. Tell the best method, conjugate beam. For cantilever, best method. No confusion. I told this one. For cantilever, ideal method. Which one? For cantilever, no confusion of what? Diagram interchanging, etc. For conjugate, cantilever, always moment area is the most useful. Okay, do one thing. Cut. Now, this all I will remove. Okay. This all I will remove. This warning also I will remove now. Nothing required. Cut. Now, make a note here. Next step is what? Calculation of reactions for conjugate beam. Remember, real beam fixed end is here. Reactions here. Conjugate beam reactions here. But remember, note, no need of calculating reactions even for conjugate beam also. Make a note, because it is a conjugate beam also is cantilever. See, real beam, we will look this side, free end side. Conjugate beam, we will look this side, free end side. Anything you want, when you find BM for real beam, look free end side. In conjugate beam also, look free end side. Or cantilever means what? Cantilever means look or consider which side. I won't tell again. Cantilever means, for easy understanding, consider which side. Cantilever means consider which side? Free end side. So here for bending moment, look this side. Here for editing, look this side. Over. Now I will not repeat. And remember, just to give warning to you, see, this is fixed end. If the load is up, there is going to be a reaction here. That is called VB dash. We don't calculate. And this load will create moment this way to balance there will be a reacting moment here, mb dash. But we are not going to calculate this. Why? Why means because anything you want here, look free hand side. Here, look this side. Here, look this side. Over. Or both the cases, consider free hand side. That's all. Now, start one by one. First, I will complete. I will go back to moment area method and close it so that then you can make out. You will tell, oh, identical statement changes. See, start. Back to moment area method. Here, why back to here? Anything I write here is moment area method. Start. Very briefly, I will tell first. Theta max is nothing but theta at free end. Free end means what? Original beam, free end of real beam. That is theta b is theta max. Start. Apply, you want the value of theta b. If you want theta b, apply first theorem. That's all I am writing. Apply first theorem. Consider the point B and fixed end here, A. Where theta B you want, theta A 0. Okay, start. Theta B minus theta A 0 equal to, those who want, you should write area of the BM by EI diagram, only area of BM by EI. See, BM by EI diagram between B and A. Start. Half into 2.4 into 144, no sign. Half into 244 into 144 plus rectangle 1.6 into 144 plus one more half into 1.6 into 336. Everything divided by EI. Tell the answer fast. When you are calculating that answer, by that time I will apply my trick and find the what? I will apply a trick and find all the answer. See, here also tricks are there. This reaction is 210. You don't bother. The building only so much? 480. Okay, sufficient. Slope at B equal to, see, I will apply the trick now. Minus 480, you calculate on. Minus 480 into 4 square divided by 2 plus 210 into, minus 480 into 4 plus 282, reaction is 210. 210 into 4 square divided by 2 minus 150 into 2.4 square. 672 is my first answer. 672 is my first answer. Tell the answer. 672 equal to 672 by EI. Therefore, your theta B equal to 672 by EI radian. You can see here, why elastic curve, that much clockwise, that itself equal to theta max over. Now, come to 672 already there. Y maximum. Y maximum is deflection at free end. Free end of real beam. That is nothing but deflection of B. To get deflection of B, you find what value? Find Y of B with respect to tangent at A. Start. Y of B with respect to tangent at A equal to moment of the area of the BM by A diagram between B and A about B. See? Moment of the area of the BM by A diagram between B and A about B. Thousands of times I told. If you write YBA, moment of the area of the BM by A diagram between B and A about B. Okay, start. Why I am not writing? Because it is repetition, 1000 times over. Half into 2.4 into 144 is the first area. Moment about this point from here to here is into 2/3 of 2.4 plus here 1.6 into 144 is the area into moment about B is 2.4 plus up to center is how much? Half of 1.6 plus moment of this triangle, half into 1.6 into 336 is the area into moment about this point. 2.4 plus from here to here is 2/3 of 1.6. Everything divided by common EI. Calculate and tell me the answer. By that time, I will apply my trick. Ayyo, minus 480. I got my answer. 2 years before independence. It is June month. 2 years before independence. Answer. Answer. I got the answer. 2 years before independence, decimal, June month. What? This much time. I applied the trick and finished everything. 1945.6, correct, because why? Independence, 1947. So, 1945, I told June month, divided by EI. Over. I also got same answer. I told 2 years before independence, 1947 minus 2 is 1945.6. Okay, start. That is your YBA, that itself equal to YB, or what? Therefore, your deflection at B equal to 1945.6 by EI meter down, that itself is Y maximum. This also fully clear. This also fully clear. Now when you go to conjugate mean method, you can make out. Then why I am writing? Because to save the time. Once I solve this question, every question where left side fixed, right side free, you can do today only by conjugate beam method. See, statement will change, calculation will not change. Okay, now start. Now that also find. What is also find? Next, slope and deflection at load point C. Okay, start. First, theta C. If you want theta C, apply the first theorem from C to A. C to A. So right here, theta C minus theta A equal to theta A is 0. Area of the BM by I diagram between C and A. Between C and A. Area, okay, right here, moment of the area of BM by EI diagram between B and A about B. For some reason I want about B here. Area of the BM by EI diagram between C and A. Between C and A, rectangle and triangle. One 1.6 into 144. Other one is half into 1.6 into 336. Common divided by EI. Tell the answer. I will apply my trick. Some are wondering, what is that trick? That trick is nothing. 1.6 plus 210 into over. See the trick. I got the answer. 80 paisa less than 500 rupees. 80 paisa less than 500 rupees. Oh yes, I told 80 paisa less than 500 rupees. 499.2 by EI. Therefore, your theta C equal to 499.2 by EI radian clockwise. Over. Lastly, deflection at C. Start. If you want deflection at C, it is nothing but displacement of C with respect to tangent at A. That is, find what value? Find y of C with respect to A. Apply second theorem. So YCA equal to moment of the area of the BM by EI diagram between C and A about C equal to between C and A whatever is there about C equal to rectangle 1.6 into 144 is the area into distance of CG, moment about C point, into only 1.6 by 2, 6 by 2 plus another half into 1.6 into 336 is the area into moment about this point directly 2/3 of 1.6. Answer full divided by EI. Answer. My trick. Yes. Number beda. You tell. I will write the answer because I can't imagine number. Okay. It is 471.04 by EI. Tell me correct or wrong. Tell me correct or wrong. Okay. Now, last answer. Therefore, deflection at C equal to 471.04 by EI meter down. Or, I will tell once again now, I should not tell, first of all, should not tell. In case of cantilever, see, I will put here. Moment area method. Wherever you want slope, first theorem from that point to fixed end. Area of the BM by EI diagram from that point up to fixed end. Over. Fixed end slope is 0. You get the slope. Wherever, if you want slope at B, first theorem from B to A. If you want slope at C, first theorem from C to A. That way. Don't by heart A, fixed end. Deflection. Wherever you want deflection, apply second theorem from that point up to fixed end. Moment of the area of the BM by A diagram between that point and fixed end, about that point. If you want deflection at B, moment of the area of the BM by A diagram between B and A, about B. If you want deflection at C, moment of the area of the BM by A diagram between C and A, about C. This I told earlier, shortcut. You don't have to write all the statement. You want slope, theta there minus theta fixed end equal to area from that point to fixed end. Deflection anywhere you want. What? Moment of the area of the BM by A diagram between those two points, by that point and fixed end, about that point. I told 1,000 times earlier. Fully clear? Now I will tell goodbye to what? Moment area method. Come back to conjugate beam method. Be careful. At the end of this problem, you should tell, hey, you will tell statements are changing, then writing way is changing, but what about calculation? You know, whatever is there, same thing here. That's why I told. Second question on fix here, free here, I am not doing. Tomorrow class, I will do one more question, right side fix, left side free. That once that is clear, close the cantilever. Why? Solve all the cantilever problems solved by moment area by conjugate beam. If you want, solve it. Otherwise, leave it. Okay, start. Now, moment area, goodbye. But remember, I wrote you because I know what I wrote there is going to come here also, calculation. So, you stay there. Start. Fresh conjugate beam method. Real beam. Fixed here, free here. BMD, I thoroughly explained, but this time for BMD, sign is required. Okay, minus. There also sign is used to calculate, but diagram, sign not written. Why? Sign given for slope and deflection. Okay, start. Now, BM by EI diagram, 0, 144, here 480. Divide into triangle and rectangle and triangle, so 144 and 336. And conjugate beam, fixed end here become free end there become fixed end. Here reaction always comes at the fixed end. Here reaction will come at A, here reaction come at B. Both the cases we are not finding reactions. Here we will look this side, here we will look this side. Clear? Here for BM we will look this side. Here for we will look this side. This side we will not see. Clear, please tell me. Clear. Okay, start. Now, one by one. First right. What? First to understand, first what they want is to get, to get maximum slope, waste of time, theta max and y max. Theta max and y max for which beam? Tell me. Theta max and y max for which beam? For which beam? Some will tell me, sir, conjugate beam. Conjugate beam is nonsense. Real beam for real beam. Just to understand, put a sketch. Here, put a sketch, fixed. See the real beam. This is real beam. A fixed here, B free here. Our real beam will bend like this. Therefore, this is deflection at B, that is the y maximum, and this is theta at B, that is theta maximum. Okay, start. Now, theta maximum is theta at free end. Free end. That is theta at B. Start. Theta B clockwise in real beam equal to slope at B in real beam equal to shear force at B, left up positive, right down positive. Shear force at B in conjugate beam equal to slope here is shear force at B, fixed end. Shear force is reaction. Reaction you are not considering. So shear force at B, look this side. Left side up is positive. 1000 times I told, shear force. Left up is positive equal to, start from here. Half into 2.4 into half into all positive. Why? Everything is positive. Why reason? Because left up is positive. Half into 2.4 into 144 by EI plus this force, this total load equal to 1.6 into 144 by EI. 1.6 into 144 by EI plus this load half into 1.6 into 336 by EI over equal to plus. Don't waste time. Why? Tell me. Is it ditto calculation? There EI comes cut, here EI comes common divided by, here EI comes side by side, or you can push EI outside also. Both are exactly same calculation. Tell me. Both are exactly same calculation. Why you are calculating? Both are exactly same calculation. Yes. Therefore, you can create magic. Yes. It is plus 672 by EI. Therefore, your theta be equal to 672 by EI radian clockwise. That itself is your theta maximum. Over. Oh, same answer. Start. Now, y maximum for the real beam equal to y at free end. Free end of real beam. Y at free end of real beam. Y theta real free end of real beam. Y max for real beam. Real beam. That is y at B. Start. Y at B. Now, y at B downward in real beam equal to bending moment at B in conjugate beam sagging positive equal to deflection here is bending moment here. Actually bending moment is, it is MB dash. But we don't calculate MB dash. Don't look friction side. Look free hand side. Start. One bending moment. Look this side. See, all are sagging. Start. This triangle. Half all positive. You can put plus outside if you want. Plus outside. Half into 2.4 into 144 by EI is the total load into moment about B. See, BM at B from here to CG is 2/3 of 2.4 plus one rectangle. 1.6 into 144 by EI is next area that loading into moment about B. 2.4 plus half of 1.6. 2.4 plus half of 1.6. Lastly, plus half into 1.6 into 336 by EI is the triangle into 2.4 moment about B plus from here to CG is 2/3 of 1.6. Tell me, is this calculation 100% same as? Compare. Tell me, is except change of statement and starting the question, leaving that one, is this exactly same as moment area method? Yes. Or tomorrow I will do one thing. See, I will solve second question with left side free, right side fixed. Then I will do one thing. Just to give more confidence in you, 2 conjugate beam question fast I will solve. Before the class, in the right corner, I will write the moment area steps there so that you can complete the question. Over. Why calculate? 19 equal to plus 1945.6 by EI. Therefore, deflection at B equal to 1945.6 by EI meter down. That itself is Y maximum. Over. Now, next be careful. I told you each and everything will tally. Not only maximum. Even if you find slope and deflection somewhere else, that also is ditto. Or conjugate beam method, moment area method for cantilever. See, simply supported completely different. See there, simply supported completely different. Cantilever, both are same. Writing the statement or starting part is, that is a common. See, this statement is common for all the questions. Calculate, important is calculation. Start now. To get what? Theta and Y at C. Okay, start. First, theta C I want. Theta C clockwise in real beam equal to shear force at C in conjugate beam. Left up, right down, positive equal to. Slope here is shear force here. Shear force here. Don't look this side. If you look this side, reactions required. Look free hand side. One rectangle, one triangle, both are left up. Left up is positive. Plus, start. This one. 1.6 into 144 by EI plus another one half into 1.6 into 336 by EI. Oh, don't tell, sir, here you wrote one below other one, there you wrote one after other one. If you tell that way, I will stop the class. Sir, change is there. What change? Here you wrote one below other one, there space is there, you continued there. Oh, yes. Exactly what you have done there. Same thing or not? Oh, this pen I can't use. It is a very light pen. I will use a dark pen. Okay. Little. It is little light. I will use dark. Is it fully clear? Okay, same. How much? Yaad calculate ಮಾಡ್ತೀರಾ? Hey, ಬರ ಇಲ್ಲಿ. 4 plus 499.2 by EI. Present the answer. Therefore, your theta C equal to 499.2 by EI radian plus means clockwise is the answer. Lastly, you want deflection theta C over deflection at C. Start. Deflection at C downward in real beam equal to bending moment at C in conjugate beam equal to deflection here is bending moment here. Look this side. Both are sagging. Plus. Start. This load 1.6 into 144, 1.6 into load, moment bending whatever C. From here you require into, say CG is here, BM at C into what? 1.6 by 2. Then plus one more. Moment of the triangle. Half into 1.6 into 336 by EI is the total load into BM at C. From here to here is this distance, 2/3 of 1.6 equal to. Wherever you want to find slope, wherever you want to find deflection, it can be maximum or any intermediate. What calculation came in moment area method, same calculation came in conjugate beam method. Moment area you write for slope, area of the BM by I diagram. Here you write shear force for conjugate beam. In moment area method for deflection, you write displacement of that point with respect to tangent at fixed end. Here you write for deflection BM at that point in conjugate beam method. Except the statement point of view, otherwise beam, BMD, here elastic curve is not drawn. Why? Because here slope and deflection come from sign convention. There we want elastic curve. Elastic curve is not drawn here. Exactly same. Plus 471.04 by EI. Therefore, deflection at C equal to 471.04 by EI meter down is the answer. Tell me, cantilever beam, left side fixed and right side free, both by moment area and conjugate beam method. These two questions, 100% clear. Those who are serious, 100% clear. And your state BMD comes there, BMD comes here. Here you write, here sign is for calculating use sign. Here sign is not written, here sign required. Then here only BM diagram. Here you are write BM by EI diagram. If minus, up is there. That is the change. Okay, that you can do. One more question I will solve. See, tomorrow I will solve right side fixed. Then tomorrow only I will solve two more questions. Second round. Then you should tell, stop. If you continue, you are wasting time. Why? Then you will realize, except the starting or statement changing slightly, calculation part for conjugate beam method or moment area method for cantilever is identical. Clear? Okay. Fully clear means this I can remove now. I can remove this one. Everything is crystal clear. Okay, now one minute. After all this explanation, see, still 8:30. I thought by the time I finish moment area method, backlog or what? Old revision. Old revision, moment area, because if you have not written that one, then what will happen here? If that is not written here, then here what will happen? You can't compare. Therefore, because of that way, I thought it may take some half an hour, 45 minutes. Finally, I thought with difficulty, I can finish by 9 o'clock. Still easily, I finished. Shall I give an extra homework for you? Same fixed and free end. Can you try today? Simple question. Shall I give an homework here? Okay. Okay. I will remove everything. You do one thing. Solve by both the methods. Solve by both the methods. A cantilever beam of length 4 meter, not 4 meter, 5 meter is loaded by UDL over entire span of 6 kilonewton per meter, and also a point load of 24 kilonewton here over. Here you find only theta max and y max. Okay, I'll fast solve it now. See, first go to moment area method. BMD. Remember, you have to draw BMD for UDL and point load separately. Remember, if you draw the combined BMD, again it will come. See, BM is 0 here, BM is maximum here. Then if you join this way, then for that BMD, see, for that BMD, this point slope will be there, equal 24. For that BMD, you cannot apply formula. Remember it? When you apply formula for a curve, it should be valid only for what? Only for only UDL. Clear or not? Okay. Therefore, what you do? See, theta max, y max required. Draw BMD. Right here. Consider UDL. Consider what? Consider point load and UDL separately. Separately. Start. First, consider the cantilever with what? Only point load. Okay. Draw BMD. 0 here. See, this is how much? 5 meter. This is 24. 24 into 5 is 120. Right here. 120. It is negative hogging. For moment area sign not required. Then consider the UDL. Then the BMD will be 0 here. Here BM. 6 into 5 into 5 by 2. Tell the answer. 6 into 5 is the total load into 5 by 2. Alright, move. Is it 75? Parabola. Is it 75? Okay, start. Now, you want moment area method. Elastic curve will go this way. Okay, this is your theta B. That is your YB. As usual, theta A is 0. This is the tangent at A. And or you want to find theta B. What you do? From B to A. What you get? Theta B minus theta A equal to area of the BM by EI diagram between these 2 points. Answer. This area. Half into 5 into 120. One more area for this curve. Area equal to 1/3 of. Remember, for this curve, 1/3 base into height. 1/3 of 5 into 75 by EI. Tell the answer. Theta A is 0. This all we solved. Therefore, you get theta B, that itself is theta maximum. Answer. Answer, theta maximum. 425 by EI. See, 425 by EI will come. Then, if you want deflection at B, apply second theorem. Find what? Find y of B with respect to A. Y of B with respect to A. YB equal to what? YB equal to y of B with respect to A equal to moment of the area of the BM by A diagram between B and A about B. You write moment of the area of the BM by A diagram between B and A about B equal to half into 5 into 120 is the area into CG is here 2/3 of 5 plus one more area plus here plus 1/3 of 5 into 75 is the area into from here to here 3/4 of 5 divided by EI. This YB itself is YB equal to answer. That itself is YB. Answer. Fast. I'll finish fast now. Time is still there. YB. Deflection will be. I did fast because why? It's already over. First of all, I need not solve by moment area. First of all, I need not solve by moment area method. Bega bega. Answer. Deflection will be 1468.75 by EI. 1468.75 by EI. Okay, now come to conjugate beam method. Okay, let me use the paper instead of hand. Sometime when I teach, I forget that what ink is there. Okay, no problem. See, start. Conjugate beam method. This is the real beam. Okay. Real beam, right there. Now, draw BM by BM diagram, right here. Bending moment diagram for point load and BMD for UDL to be drawn separately. So, one diagram will come like this. You already know it. How much? 120 here minus. One more diagram will come this way. Parabola. Manage. Okay. Parabola 75 minus. Okay. Now, draw BM by EI diagram. One more is there. Okay. Now, minus means upward. And below write conjugate beam. Fixed end become free end here. Free end become fixed end here. AB, AB. AB, AB. Okay, start. Now, theta B in real beam equal to shear force at B in conjugate beam. Left up, right down, positive. Shear force equal to plus half into 5 into 120 by EI plus this area 1/3 of 5 into 75 by EI. Tell me, is this calculation did same as that one? Tell me, is it same as that one? Is this calculation same as that one? Any one small change? Tell me, no. So why waste time? Equal to what? Equal to plus 425 by EI. Then write theta B equal to 425 by EI radian clockwise. Then if you want deflection at B in real beam equal to BM at B in conjugate beam, sagging positive. Deflection here is bending moment here. Plus how much? Half into 5 into 120 by EI is the total load into CG is here 2/3 of 5 plus once again this area is 1/3 of base. Base how much? Base is 5 into ordinate is 75 by EI. Forgot right ordinate here. 120 by EI, 75 by EI. Okay. 75 by EI into 3/4 of 5. Oh yo. Same answer. 1468.75 by EI. Now, crystal clear. Any question now onwards, if we can solve by moment area method, when left side is fixed, right side fixed, I will solve one question. Till I solve it, any question we solved cantilever with left side fixed, right side free by moment area, can you solve by conjugate beam now? Tell me. Any question which we solved in the class where left side is fixed for cantilever, can you solve by conjugate beam method now? Solved by moment area method earlier. Can you solve it by conjugate beam method now? Fast. Can you solve it by conjugate beam method? You are not telling. Yes, okay. Now, 1 minute, there are people who are highly intelligent. I will tell what they will do. See here. What they will do is, when they draw BMD, they will not separate. I have seen people, they will not separate. BM0 here, BM here is how much? Tell me, what is the BM here? 24 into 5 and also 6 into 5 into 5 by 2. Tell the answer here. 24 into 5 for point load and 6 into 5 into 5 by 2 due to UDL. Tell the ordinate. It has to come sum of these two. Is it 205? Is it 200? Is it 195? Is it 195? 195. Then they will tell UDL is there joined by parabola. Okay. Now, this parabola and this parabola, both are same parabola. Tell me. This is the parabola for a cantilever with only UDL. This is parabola for cantilever with the UDL and point load. Both are same. Both are same or different? They are different. Actually, they are not same. Now, foolishly, for this one, they will apply area equal to 1/3 base into height, and CG they will take at 3/4 here. Then their answer is, tell the answer, 1/3 of 5 into 195. What is their answer? Their answer is, for slope, 1/3 of 5 into 195. EI not required. Tell their answer. Their answer is 1/3 of 5 into 195. It will be different answer. It will be 325. Their answer is 325. Real answer is 425. And their deflection equal to what? 1/3 of 5 into 195 into, they will write 3/4 of 5. Tell their answer. Their answer deflection, 1/3 of 5 into 195 into 3/4 of 5. Their deflection, 1 to 18.75. 1 to 18.75. But our answer is 1468.75. See, their answer 325. Our real answer is what? Real answer is 425. Their answer is 1 to 18.75. Our real answer is 1468.75. Who is correct? They are correct or we are correct? Whether they are correct or we are correct? Who is correct? They are correct or we are correct? One of them is wrong. We are correct. Or sometime they will tell, no, this also is correct. You made a mistake. Do one thing. Tell them, take your calculator. Okay. Cantilever with point load. What is the formula for slope? Free end. WL square by 2EI he will tell. Calculate. W, how much? 24 into 5 square divided by 2. Calculate. 24 into 5 square divided by 2EI is the slope due to point load. Okay. Plus slope due to UDL. WL cube by 6EI. Yes, I know it. He will tell. Plus 6 into 5 cube divided by 6. Press the equal button. Tell them. Press the equal button. See what comes. Oh, my calculator is not on. What is this? 24 into 5 square divided by 2 plus 6 into 5 cube divided by 6. Press the equal button. Tell the answer. Answer. Press the equal button. Press the equal button. Answer. 24 into 5 square by 2 plus 6 into 5 cube by 6. Answer. 425. Who got 425? Whether you tell them whether your method came 425 or my answer is 425. Oh, you are right. That's why you are wrong. And deflection for point load, WL cube by 3EI. For UDL, WL power 4 by 8EI. I will check it. 24 into 5 cube divided by 3EI plus 6 into 5 power 4 divided by 8EI. My calculator is showing 1468.75. And that is the answer we got by this method. We got by moment area. We will get by double integration method. We will get by Macaulay's method. We will get by strain energy method. We will get by unit load method. We will get by flexibility matrix method. We will get by stiffness matrix method. Whatever you do, same answer will come. No method will give different answer except foolishly applying formula for combined a curve which is due to both only UDL and also point load. Your formula is applicable only if it is UDL and 0 to maximum. This I told you earlier. Okay, over. Now, see, sorry, I am harsh because they make mistake and defend their mistake. Sometimes they defend the mistake. Around 2 years earlier, when I was free, I have not opened my structural engineering channel with a good intention. Some channels I commented, that formula you can't apply. You know what reply came? You first learn the subject, then only start commenting. I got a screenshot. He commented, then I removed because if I maintain the comment still, now it will come comment by not my name. The moment I change my Google account here, it will come comment by case and structure engineering classes. So I removed all the comments. I got the reply. First you learn the subject, then start commenting. Okay. I told, sorry sir, you are great. Okay. Okay, clear? Okay, tomorrow I will make the other cantilever perfectly clear and I will solve 2 more questions. For left side fixed side free 1 question, right fixed left free 1 more question, because by that much time is not required tomorrow. You know everything. Tomorrow we will conclude the cantilevers. Clear? Tomorrow we will conclude the cantilevers. Then those who are serious will open the moment area page and keep on solving by conjugate beam method. You will tell after some time, everything I solved by this method. Okay, good. Okay. See you tomorrow. 10 minutes extra break for me today. Because my class is at 9:15. Little freedom I get or rest I get now. 10 minutes extra. Tomorrow we'll meet.